Okay, this is the next unit in Algebra 2. The unit is called Rational Functions, and this lesson today is called Simplifying Rational Expressions. Okay. So the definition to start off with is a rational expression. A rational expression is a quotient, meaning you're dividing, a quotient of two polynomials. Examples include the following: x minus 3 over 5x plus 1, that's a rational expression. This is also a rational expression, and this is also a rational expression, okay? So today we're going to be doing simplifying rational expressions. Since rational expressions are ratios of polynomials, you can simplify them the same way you simplify fractions. Recall that to write a fraction in simplest form, you can divide out common factors in the numerator and the denominator. So for example, 9 over 24 can be rewritten as 3 times 3 is 9, and 8 times 3 is 24. And you divide out the common factor of 3 over 3, and you get 3 over 8, okay? All right, so just one thing to be careful of is when identifying values for which a rational function is undefined, you must identify the values of the variable that make the original denominator equal to 0. And I'll talk about that more when we get to the examples, which we'll get to right now. I have 6 examples in this lesson. So we'll start off with a nice, easy one. Simplify. Identify any values for which the expression is undefined, okay? Now, the reason why this one is easy is because this example is already factored, so you don't have to factor this one. So what we're going to do is we're going to divide out the common factor. Write that over here so you can see what I'm doing. Divide out common factor. Okay. So in this case, I'm going to divide out the x minus 2, because that's the common factor. So that leaves me with x plus 7 over x times x plus 5. But you have to make sure that you identify the restrictions, okay? Meaning what values make the denominator equal 0, because you cannot have the denominator equal to 0. So I'm going to say right here, x cannot equal 0. But you have to go back to the original denominator. So even though there's no x minus 2 in this denominator, there's an x minus 2 in the original denominator. So it means x cannot be 2, because if you have 2, you have 2 minus 2 is 0. You can't have that. And x cannot be negative 5. Put my answer like this. And let me just jot down a note, okay? So just so you know what I'm doing, these are the restrictions. Okay, I'll say the denominator cannot equal 0. Don't forget about the fact that you divided out. I'll jot that down too. Okay, those are the values, the restrictions, those are the values that make the denominator equal 0. You cannot have that. Don't forget about the fact that you divided out. Example 2, simplify. Identify any x values for which the expression is undefined. So first thing you have to do is you have to factor, because this one is not factored for you. So let's factor first. Okay, factoring the numerator. Look for two numbers that multiply to -2 and add to 1. So it'll be x plus 2 times x minus 1. Factor the denominator. Look for two numbers that multiply to -3 and add to 2. So it'll be x plus 3 times x minus 1. Now you're going to divide out the common factor of x minus 1. And it leaves you with x plus 2 over x plus 3. Then you have to state the restrictions. X cannot be -3, and x cannot be 1. If you're confused about how I'm getting the restrictions, think about it like this. Okay? Basically what you're doing is you're taking the denominator, so each factor in the denominator, which in this case, let's just take x plus 3, and you're saying x plus 3 cannot equal 0. So that means x cannot equal -3 when you subtract 3 on each side. You take the other factor, do the same thing. X minus 1 cannot equal 0, so x cannot equal 1. That's essentially what you're doing. Okay, like I said, we have 6 examples today. Let's try example 3. Again, we're going to factor first. Okay, factoring the numerator, that has a GCF of 4. So you take out the GCF of 4, and it leaves you with x minus 5 in parentheses. 4 times x is 4x. 4 times -5 is -20. Factoring the denominator, x squared minus 25, that is the difference of 2 squares all day. A squared minus b squared equals a plus b times a minus b. A squared minus b squared equals a plus b times a minus b, so x squared minus 25 would factor to become x plus 5 times x minus 5. Divide out the common factor of x minus 5, and it leaves you with 4 over x plus 5. The restrictions, x cannot be -5, and x cannot be 5. I usually write my restrictions like this. I just list them all in one in case there's a lot, but you can write each one separately. You can say x cannot be -5. You can say x cannot be 5. You can write them all separately if you want. Okay. Let's move on to example 4. Okay. What I'm going to do for this one is I'm just going to rewrite the numerator in standard form because I like to have it in standard form. I'm going to rewrite that as -x squared plus 4x. I like it in standard form. Over x squared minus 2x minus 8. For the numerator, I'm going to factor out the greatest common factor. And I'm going to take out a -x. I'll explain why in a minute. That'll leave me with x minus 4 in parentheses. Factoring the denominator, look for two numbers that multiply to multiply to -8 and add to -2. So that'll be x plus 2 times x minus 4. And now you probably see why I took out a negative x, because by taking out a negative x, now I have a common factor of x minus 4, which I'm going to divide out. And my answer will be negative x over x plus 2. And now we have to take care of the restrictions. X cannot equal negative 2, and x cannot equal 4. Okay. All right, 2 more examples. Okay, last page. Now, for this problem, you cannot factor the numerator. There's nothing to factor in the numerator. There's no common factor. So you have to factor the denominator. But this is not an easy factoring problem because it's not 1x squared. So I'm going to factor it off to the side. Okay. I'll say factoring 3x squared plus x minus 4. Okay, so remember, when it's not 1x squared, you have to do the long factoring. First, you're going to do 3 times negative 4 is negative 12. What multiplies to negative 12 and adds to the 1 in the middle? The 2 numbers and multiply to negative 12 and add to 1 in the middle. It'll be negative 3 and 4. So again, 3 times negative 4 is negative 12. You have to find 2 numbers that multiply to that negative 12 and add to the 1 in the middle. So it's negative 3 and 4. So I replace the x with negative 3x plus 4x. Now we factor out a 3x. Now we do factoring by grouping. Take out the common factor of the first group, which in this case is 3x. It leaves you with x minus 1 in parentheses. Take out the common factor of the second group, which is a 4. So it leaves you with x minus 1 in parentheses. The parentheses match. The x minus 1 gets factored out to the beginning. And everything else, in this case 3x plus 4, goes in the second set of parentheses. So that's how you factor that. So you factor it like that. Okay, so now we're going to divide out the common factor of 3x plus 4. And it leaves you with the numerator is just going to be 1 because there's nothing left, not 0, 1. 1 over x minus 1. For the restrictions, x cannot equal 1. And again, if you're struggling with the restrictions, the other factor was 3x plus 4. So you do 3x plus 4 cannot equal 0. Subtract 4. And then divide by 3. So x cannot equal 1 and x cannot equal negative 4/3. All right. Now let's move on to the last problem. For this one, you're going to have to factor both the numerator and the denominator the long way. So let's start by factoring the numerator. I'm just doing this off to the side, and I'm writing what I'm doing, that way you're not confused. Okay, I'm factoring the numerator right here. Okay. So 6x squared plus 7x plus 2. 6 times 2 is 12. Looking for two numbers that multiply to 12 and add to the 7 in the middle, which in this case is 3 and 4. So I rewrite the middle term as plus 3x plus 4x. The GCF of the first group is 3x, so I factor out the 3x. It leaves me with 2x plus 1. The GCF of the second group is 2, so I factor that out, and it leaves me with 2x plus 1. The parentheses match, so that gets factored out to the beginning. 2x plus 1 times 3x plus 2. On to the second part, factoring the denominator. You're looking for two numbers that multiply to negative 36, because 6 times negative 6 is negative 36. Two numbers that multiply to negative 36 and add to the negative 5 in the middle. So it'll be negative 9 and 4. Then do factoring by grouping. The GCF for the first group will be 3x, which leaves you with 2x minus 3. For the second group, the GCF will be 2, which will leave you with 2x minus 3 again. The parentheses match, so factor that out front, 2x minus 3 times 3x plus 2. So this is going to be my new numerator, and this will be my new denominator. So let me go and rewrite those. Divide out the common factor of 3x plus 2. And it leaves you with 2x plus 1 times 2x plus 1 over 2x minus 3. For the restrictions, x, you're going to do this cannot equal 0, and this cannot equal 0. So add 3 divided by 2. X cannot equal 3 halves or negative 2/3. Those are the restrictions. Okay, and that's the end of that lesson. Okay, again, this is the new unit. The unit's called rational functions, and this was the first lesson. It was called simplifying rational expressions.